Hi, I'm Sandon Jacobs, Senior Developer Advocate at Confluent. And today we're going to talk about building data pipelines, specifically how we can utilize data governance and a streams first approach to proven to build proven event-driven real-time insights. Before we start, I want to assure you that you don't have to be an Apache Kafka guru to follow along. If you've been around data engineering, this talk should resonate with you. So let's jump right in and get started. Let's join this team of analytics engineers. They're huddled up trying to figure out why the ETL jobs are failing again. Does this picture seem familiar? Perhaps this just gave some of you a flashback, or maybe you're looking at something like this in Slack or Teams right now. The latest reports aren't live, and there's a meeting in the C suite in 2 hours. This is the third time this has happened this week. Now, to their credit, these frustrated warriors always deliver. They plow through their lunch time and their lunch hour, and they stay late in the evening, and they get pizza and donuts and coffee force fed to them. They figure it out every single time. But they rarely get time to investigate the root causes of these issues in the architecture. Uh, there's always another requirement. There's another fire to fight. But in large part, it's because our data pipelines look a lot like this. Am I right? Or maybe they look more like this. At some interval, be that daily or hourly, or at best every 15 minutes, we run some set of queries, some jobs on multiple data stores to get these data dumps of raw data about the most recent transactions and updates in our ecosystem. And we use those to build these low fidelity, inconsistent, and stale snapshots of data. And we store them on a file system or maybe object storage somewhere. Then we start the process of scrubbing this data and transforming it into something useful, something that we can use to build the reports for the folks upstairs and make them happy. Then there's the cost and the complexity of remodeling and reprocessing this data time and time again. Teams often create local versions of the data. They do that same processing over and over again. And that's expensive, both in terms of wasted hours and in terms of just the compute cost of reviewing those data sets over and over again. And third is data quality. It's probably the most important tenet here, is that the quality of that data and the trustworthiness of that data is pretty low. In the application side, the schemas of that data drift. And so what happens when that drifts? We end up with garbage in our data warehouse or our data lake. And the issues flow downstream from there. And fixing this is just a manual, multi-step process that's really tedious. So we reconvene our frustrated team of data engineers huddled around even more pizza, more coffee, more donuts. And by the way, who came up with this developer diet? Seems like a great idea for folks who sit most of the time, am I right? But I digress. Once again, they find the problem, and now they have to fix that same problem in 5 or 6 places because we got more pipelines now. And they have to retest all of it, and over again is Groundhog Day, right? Same stuff, different day. Meanwhile, there's our teams of application developers and microservices developers who are creating applications and microservices to service user transactions or partner transactions, how people interact with our business. Why do these folks look so much happier than the analytics engineers? Well, for starters, years ago, the monolith was refactored into microservices. And those microservices were then re-architected to become more event-driven, more reactive. These folks read the reactive manifesto, didn't they? And the apps now send data to Kafka, Apache Kafka, where they trigger behaviors of other services instead of talking point to one another over protocols like HTTP or RPC. And these are the events that are their data contract with one another. These services subscribe to event streams that allow it to perform its duties, and they publish events to notify others. Maybe we have something like change data capture in the mix to capture the transactions from our data stores, be that our relational databases or NoSQL databases, to publish this data to Kafka, kind of democratize this data to the rest of our organization. Why is there this brave new world of events? Largely due to the way that we, users, consume and create data every day, or every second of every day. especially since the smartphone became the first thing we reach for every morning and the last thing we touch at night, from our coffee orders to our traffic reports to the weather to our social media. We're talking about events all day long. And so there's got to be a way that we can get our analytics engineers off of this emotional roller coaster of, yeah, we created this new requirement and we've delivered it to the business and we're giving these insights to, oh my God, the house is on fire again. I mean, the organization learned the benefits of event streaming and this microservices architecture, and where we applied it to the microservices architecture. Can we use that event streaming paradigm in the analytics realm as well? First, let's define these data estates, what they do, and then we'll dive into the innovations that allow us to reimagine software architecture in each of these data estates. Okay. This is how our data ecosystems have typically organized themselves into an operational state that we were talking about earlier, where our happy microservice engineers are living, and this is where our apps and our microservices live, and they own their own data sets and their own data stores, and they communicate over some event platform, most likely Apache Kafka, because that is the default standard for event streaming these days. Then we have the analytical state where our data lake or our lake house or our data warehouse lives. And the goal here is to build data products to provide insights in a line of business view of what our business does. So we have our transactions in the operational state, but how do we look at that from the view of what does it mean to the bottom line? And in that analytics estate over the past couple of years, rather, there have been these open table formats that have emerged in this space, namely Apache Iceberg. So rather than extracting multiple copies of the same data over and over again in some batch interval, let's consider this streams first approach. And at the center of that is Apache Kafka. Many of us already have these streams in the operational state, right? So let's leverage that knowledge and that investment to create and store reusable data streams and get out of this scheduled ETL business. So what is Kafka? Let's review that real quick. It's a distributed event streaming platform where the data is immutable and replicated within the cluster, so that makes it resilient and fault tolerant. There are client libraries for all of your favorite programming languages like Java and other JVM languages, .NET, C, C++, Python, Go, JavaScript, and we're able to connect virtually any external system to Apache Kafka via another part of the Kafka ecosystem, which is Kafka Connect. So we can source data from external systems, we can sync data to external systems, and treat everything in a streams first approach. And for these reasons and many more, 80% of the Fortune 100 trust Apache Kafka as a part of their data infrastructure. But let's talk about stream processing. After all, we have the events in our event stream. We need to process them. And that's where Apache Flink comes into play. Flink is a framework and a distributed processing engine for stateful operations. You can operate on bounded data like files or tables on the database, and unbounded data like data streams, Kafka topics. Data sourced into Apache Flink is manifested as Flink tables and operated on using some programming abstraction to fit the use case or the user that's using it. Let's talk about these personas real quick. For, say, your data scientist, someone in the analytics estate whose lingua franca or their love language is SQL. This might be Flink SQL, which is an ANSI SQL abstraction for Apache Flink to be able to create statements for either your exploration or for creating persistent Flink jobs to run on the Flink cluster. For the data engineer or the software engineer personas, that could be Python or some JVM language, because that's where they made their investment. And they may build and package an application using, say, the Flink table API, which is another layer of abstraction for Python and JVM developers, or they may go even lower level to the data stream API and submit those jobs to the Flink cluster in the table API or the data stream API. Flink can maintain application state over time, and when working with unbounded data like a Kafka topic, that means that the state can be reevaluated as events roll in, and we can do things like time windowed operations on events as they come into our ecosystem. Now let's define an industry standard way to land this data in the data lake. So what's the knock always been on analytics stores or OLAP stores over the years is that queries are so slow. Well, these open table formats, they build on the formats that we've known and are tried and true over the years, like Parquet, Apache Parquet, and they add a layer of metadata over the top of them so that when you query for your data, you're actually asking the metadata where my data lives in this file tree. And so now you have a query optimized view of the data in your analytics estate. The two popular formats here being Apache Iceberg and Databricks Delta Lake. And these open formats also come with something called a catalog. And that catalog is where the metadata is efficiently maintained. And you also get other features like table schema evolution. There are a number of integrations with these open table formats from many open source projects and from vendors as well. Some of these logos that you recognize here would be Snowflake, Trino, Apache Spark, Dremio, even JDBC, and many, many more. So let's go back to the problem that we were starting with here and work our way into how we can apply these tools to make life easier in the analytics estate. That legacy method of creating high quality, business ready data products in a tedious and error-prone exercise, really. If you look at this diagram, we have our raw data, and these colors that we see on our data are representative of what we call the medallion architecture. This raw data is bronze quality. It's not ready for prime time yet. It's really the data dumps that we took on some batch interval from our operational state. And we do some transformations and some aggregations on that, and we mold it into these cleansed data sets that are represented here in silver. That silver data is the building blocks for the actual data products that are business ready and ready to fulfill our gold level quality data that is ready to fulfill our requirements to our end users. Problem here is that, again, let's go back to our compute costs. We've done this processing over and over again on a lot of the same overlapping data sets. And that data, because it was loaded in batch, is also probably stale. So there's quality issues and maintenance complexities all over the place here. I think there's a better way, and that starts with shifting the processing and governance of this data to the data streaming layer and shifting left. Let's leverage the event streaming platform we're relying on in the operational state and the transformations that we're performing on this raw bronze data before we use our stream processing layer, such as Apache Flink or Kafka Streams, or maybe even Apache Spark. And now we have what was formerly this silver data landing in the data lake. And these are the building blocks. This data is already cleansed by the time it hits the data lake, and it's ready for us to build our gold quality data products on top of. The stream processing layer and the applications in the operational state all adhere to those data contracts, as does the data that lives in our analytics estate as well, defined in this data governance layer. So let's zoom in on data governance, which is really the crux of what we want to talk about here. Stream governance means that we apply industry standard serialization formats to our data streams, namely using something like Apache Avro, Google Protobuf, or JSON with schema. And we define data contracts here. So a data contract consists of your serialization format, how the data was actually serialized to your Kafka topics and into your streams. It also consists of the schemas of your data and a way for that schema to evolve over time. Schemas aren't static. Requirements change, schemas are going to change, the format of our data change. So how can we ensure that we're going to have quality data in our streams, no garbage in our streams, and we're adhering to a data contract that our producers make sure that they're producing high quality data so that our consumers can run without the issues that we saw in our batch oriented way. At the risk of sounding like a salesperson here, at Confluent, we're encapsulating this sort of paradigm into a product we call Tableflow, which is available to our Confluent Cloud customers. In Confluent Cloud, we have a hosted Kafka solution along with data governance and a hosted stream processing layer that's built on Apache Flink. And since we have these data contracts defined and these schemas defined for our data streams, we can derive from those schemas the schemas of your tables for your open table format of your choice, be that Iceberg or Delta Lake. And so now your topic data flows directly into an open format table, thus the term table flow. So at the click of a button or by updating a Terraform manifest, you get that functionality in Confluent Cloud. So let's land the plane. I hope you've seen now how we don't have to live in this data mess anymore, and the brittle pipelines of yesteryear can be reimagined using data streaming platforms to get business insights in real time. We don't have to wait on the hourly jobs to run or the 15-minute jobs to run. We have the tech stack at our disposal, and it's just over there to our left. So that's going to be it for today. And I hope that you enjoyed this talk. I hope that you gleaned from it the ways that we can clean up the data mess. Thanks for joining us.